Okay, let's look at the exponentials again. It's going to be the application aspect. Now, there are countless ways to apply exponentials. I can't show them all to you, so you kind of have to be able to recognize that a situation is possibly exponential and then apply it. It's going to be a little more straightforward in here. You'll be asked to, in the exponential section, it's probably an exponential problem, right? But I mean, you're looking at finance, population growth, exponential decay in carbon dating. I mean, there are just a number of examples. Here's one that I'm dealing with right now. It's tax season, right? You guys don't care yet, do you? Anyways, my wife and I both have jobs. We also have at least a part of 3 different businesses that we own. Okay. I have an oil field business. My wife is a doctor. We have a business for her medicine work. And then we are a party to an agricultural business, so we farm hay and stuff. Well, we own equipment for the farm. We own laptops and medical gear for my wife's work. We own some mud logging and geosteering equipment, computers, gas detection, etc. for the oil fields, right? Well, every year we use those and the value depreciates, right? So my computer I purchased for $685 last month. Next year is probably gonna be worth like $400, right? So I can actually write that off on my taxes as an expense. So your depreciating value, you can write that off. We have a really good accountant who does a lot of this for us, but I have to actually give this guy the numbers. So let's say that laptop that I purchased last month, $685. Let's say it depreciates 30% a year. Let's just throw that number out there. What number am I going to put on my taxes in 2 years? So how much is it worth? And I have to figure this number out. Okay, accountants are great. They know all the tax information, but I still have to send them the numbers they need. We price, if you own businesses, you're going to spend a lot of money on tax prep. You spend about $1,000 a year to have an accountant. And that's all they do. Okay, so. How much? 144? Okay, we're going to check that. So David argues that it's $144.
That's not just worth that much. Which weeks? Should be how much? Is that what you're saying?
Let's check his answer. So next year, I'm going to take 30% off after a year, right? So there are a couple ways to do this. I prefer to multiply it by 0.7. This will give you the actual value. And any calculator. $479.50. David, I'm pretty sure you're not gonna be right. That's after 1 year. You could also do this. 685 times 0.3, but then you have to do subtraction too, right? So that would be 218, no, 215, 205. And then you have to take 685 minus that. So we get the same answer either way. Take your pick. I prefer the first one because it's less work. And then the second year.
I have the total of 479.15 and kind of like 3 years.
How much?
335.65.
35.
335.65.
And that's the value currently of that laptop after 2 years.
I find this one stuff.
Now you could say that the laptop I replaced, I had it for 6 years, it's probably worth $50, right? But it still worked great. We just replaced it because it was getting old. New hard drives, new batteries, etc. Started to cost us a little money. There you go. You can all sometimes. So there are 2 ways to ask this question. How much is it worth after 2 years? How much is the value depreciated after 2 years? Okay. So you have 2 different ways to answer that question. But there's an example of exponential functions because you're doing it 30% a year. 30%, 30%, 30%.
But you actually do that with like the line.
Yeah. It would be I think we have a starting value and something to the x. I'm pretty sure it's going to be 0.7. That would be your formula for the exponential function. This is the same work, you're just putting it, in a really mathematical sense. Thanks, Ms. Wade. Great, so tax is something you're gonna have to deal with. Sad life, yeah. You could actually deal with it now and you guys would get most of your money back. So yours is only a 1-page form in 1040 easy. You get most of your money back if you're working. So I would encourage you to start doing it. Okay. There are a couple examples in the book. Let's go to the savings account. Okay. Let's say we have a 5% compounded day. Do you guys know what compounding interest is? Some of you don't, but many of you do not. Okay, compounded interest. Let's do a little finance session here. Let's say I put $1,000 in the bank as compounded monthly at 5%. That means every month they're going to times by 1.05 to get your new value once a month. Okay. So you can do monthly. Should be an L or something. You can also do it daily. That will be every day they compound the interest. You can do it yearly, once a year. You can do it compounded continuously. Okay, and I'll show you a better one for that in the next couple of days. It involves a number called E, just like pi. But, so you can do daily, continuously, daily, monthly, yearly, and you could do it every week. Okay, you can do weekly. There are a number of ways to compound interest. The point is, if I do a yearly compound of 5%, once a year, they're going to compound that at 5%. Monthly, every month at 5% per year, they're going to divide that number by 12. So every month you're going to get 5/12 of the percent. Right? What about daily? What's that going to be? And then continuously is one we're not gonna mess with yet. Like I said, something, but, you kind of get the idea of what compounded interest is. So let's say you have, $5,000 in the bank, and it's compounded at, give me a percent. That's pretty big.
Three.
Okay. Three's a little more reasonable. Right now, savings accounts are getting like 0.1%. Okay, that's why you don't have much cash in the bank. Okay. Compounded, take your pick. Okay. What time period do you want to say? 4 years? Okay. How much is available after 4 years? This is not contributing any more money to that bank account. This is just starting at 5,000 and letting it sit there. Okay, let it do its job.
5,636.64.
We're gonna check your answer. 5,634.
36.
3664.
64.
Okay, here's your equation. Notice it's an exponential here, right? So we have a time period, and we have a rate, and we have the compounding, and then we have the principal value. What's our principal? 5,000. Our rate, 0.03. What's our end value? Monthly, so that'd be 12. 12 times per year, right? So we see that if it was daily, we put 365. Right? We put 12 here again, and then number of years is our time period. Okay, so put your brain mindset in, this is all in years, because it's 3% per year. Probably write that down. So everything in here is in years, 12 months a year, 4 years, etc. You calculate that answer, you disagree. Agree, disagree? Probably just, if it's not perfect, it's pretty close. Yep. We've done this before. So again, I can't show you all the examples, but you just know what these variables mean and plug your numbers in. Okay. What if this was compounded daily? Would there be a difference in how much is available at the end? More or less? Let's check. You taking bets on that? No? No. This is not about luck.
Estimation on what's like.
Compounded daily. Anybody have a number?
5,637.46.
Oh, you just made 82 cents. Nice work. Yeah, there's not a whole lot of difference in small sums of money. But if this was $1 million, can you imagine that difference would grow quite a bit? So be wise when you select bank accounts. You want higher interest rate, and you want to be close. If you can get a continuously compound account, I've never heard of one, but if you can, that's where you want to go. The more compounding you get, the better. Okay, so if you're looking for bank accounts in the future, that's a good thing. Right? There's an example of bee populations in here. Do you want me to show you the population example? Pretty good. Good. The formula is a touch different. Again, time, rate, starting value. They all have the same format. All these exponential functions have the same format. They just have different specific applications. But again, starting value, rate, and time. Okay.
Population is gonna have a lot more involved in, so you're not gonna.
Oh, if you get that far into it, yeah. Yeah. The applications that you're gonna worry about, we're just gonna say your population is increasing at 2% a year.
Yeah.
So, no, that would include everything. Like right now, we're about stable in the United States. Because people are having less children. How many of you want to have 6 kids? No, two's my limit. I'm good.
Yeah.
But that, two kids is about the point where population doesn't grow. Number of people dying and the number of people born is about the same, so there you go. Unless you're in China, they can have 1 child and their population's still booming. There you go. Go to the basketball games. Let's not do it until Thursday. Or you could finish it, you got 10 minutes. I spoke a little more next year.
I use it for